Welcome to Virtual CB1A. This is Miss Rena, and this is Week 2, Lecture 1 of Mathematics, Investigation, and Modeling. Today, we will talk about functions represented by graphs, tables, and equations. For the learning objectives, at the end of this lesson, you are expected to identify functions through tables, graphs, and equations, and also recall the vertical line test. We discussed before that a function is a rule of correspondence. Sometimes it is represented by tables. A function may be represented using table given that no two values on the set of input x is mapped to the same element in the set of outputs. Now let's consider the following tables below. By definition of a function, each element in the set of domain should correspond to just one value in the range. Let's start with number 1. Take notice that every number in x corresponds to just a single value in the set of f of x. 1 is mapped to 3, 2 is mapped to 4, 3 is mapped to 5, 4 is mapped to 6, and 5 is mapped to 7. So this is an example of a function. Now let's move forward to number 2. Same is true for number 2. Even if negative 2 and 2 share the same value, and that is the value 4. And negative 1 and 1 also share the same value, that is 1. In the set of f of x, this will still qualify as a function because each number x is mapped to only one value in f of x. Again, this is a function. Now let's look at number 3. If you will take notice, 4 is mapped to two different values. Those are negative 2 and 2, while 1 is mapped to two different values, negative 1 and 1. This violates our definition of function. Therefore, this is not a function. So in summary, when you are represented by a table, always examine the association between x and f of x. If every value in x corresponds to just one value in f of x, then it is a function. Okay? Alright, that was good. Now let's look at the following equations. Let's start with number 1. Say for example, you are given with f of x is equal to x plus 2. Let's evaluate the function at some points. For example, the points that I want to use are 0, 1, negative 1, and 100. So let's start with f of 0. Let's evaluate our function. It is 0 plus 2, which is equal to, this should be 2. Okay, next we have f of 1. That is 1 plus 2 is equal to 3. And f of negative 1 is negative 1 plus 2, which is equal to 1. Finally, we have f of 100. We have 100 plus 2 is equal to 102. Now that we have evaluated our function at some points, let's make an analysis. Let's analyze. If you expand your set of values for the input and consider the whole set of real numbers as your domain, Do you think you can ever find an element in the domain that is mapped to two different values in the range? Yes? No? Okay, the answer is no. You can never find an element in the set of domain mapped into two different values in the range. Therefore, this is, again, a function. Now let's look at equation number 2. Same is true for number 2. Though values in the domain with the same absolute value, for example, I want to use 2 and negative 2. They have the same absolute value. 1 and negative 1. 10 and negative 10. Though these values, 2 and negative 2, will yield you the same value in the range, same with 1 and negative 1, 10 and negative 10, let's try. F of 2 will give you 2 squared, which is equal to 4. It will yield you the same value in the range as f of negative 2, because f of negative 2 is negative 2 squared, which is also equal to 4. Same is true for f of negative 1 and f of 1. Both of these will give you the value 1 in the range. For the case of negative 10 and 10, it will give you the value 100 in the set of outputs. So again, even though you will yield the same value in the range for inputs having the same absolute value, still it will qualify as a function because each input x will give you just one value for f of x. If you are going to expand our domain into the set of real numbers, this will also still be true. Now let's go to the final equation, number 3. Now, let me ask you this question. What do you know about the square root of a number? Okay, if we extract the square root out of a certain number, for example, let's use oops. Just wait a moment. For example, let's use 4 because it is a perfect square. And also 1 and 0. Okay. So if we extract the root or the square root out of negative 4, my pen is not working. I'm so sorry. Just give me a moment. F of 4 is equal to the square root of 4. Okay. What values are you going to arrive with? Alright, you are going to arrive with positive 2 and negative 2. You will get two different output. One is positive and the other is negative. Same is true for 1. So the square root of 1 is positive 1 and negative 1. So you will get two different values as well. This violates our definition of a function. And again, this is not a function because one element in the set of our domain corresponds to more than just one element in our set of outputs or our range. So this is not a function. Okay? I hope that was clear because now we will move to graphs. Earlier, when we evaluated the equation at some points x, we were able to come up with values in the range, which can also be written as ordered pairs. If you still remember, we used certain values such as 1, 100, and what other values did we use? Let me just review. 0, 1, -1, and 100. Okay. So at f of 1, we arrived with 3. At f of -1, we arrived with 1. At f of 100, we arrived with 102. And at f of 0, we arrived with 2. So from here, you can come up with ordered pairs. We have 0, 2, 1, 3, -1, 1, and of course, 100, 102. We know that ordered pairs corresponds to a point in the Cartesian plane, right? So upon listing down the ordered pairs, we can plot them on the plane and draw a line or a curve, whichever is more appropriate, to find the graph. And also, you have prior knowledge about graphing. Tama? You know that the given equation here is a linear equation. And if we have linear equation, all we have to do is to analyze what the slope is and what the y-intercept is. And from that, we can plot the y-intercept and follow the number of times that we are going to move up and move to the right or left by using the slope. So here you can use the idea that the y-intercept is 2, so our graph should be passing through positive 2, and our slope is 1. So for every one movement up, you are going to make one movement to the right. So this is 1 point in our line, which is already given here in our set of ordered pairs. So we have 0, 2, 1, 3. Also, 1 or -1, 1 is a point on our graph, and so is 100, 102. But we are limited by the space in our Cartesian plane, so we cannot plot that. So if you have at least 2 points, you can already draw your line. Just connect the points and extend them indefinitely on both directions. You will get the graph of the given equation or function, linear equation or linear function. So that's it. Now let's go to the second one. For here, again, you can list down the ordered pairs derived from evaluating your function. Earlier, we used, if I'm not mistaken, 0, 0, 0. We have 2, 4, -2, 4. What else? -1, sorry. -1, -1, 1. And finally, 1, 1. So we can plot these points. And also, you already have, I assume that you already have knowledge of quadratic functions. So it's up to you. You can evaluate the function at some points, or you can also use your knowledge about quadratic functions in graphing this equation. So we have 0, 0, 1, 1, 2, 4. Negative 1, 1, 2, 4. If we are going to extend this, we know that negative 3 will correspond to 9. And positive 3 will correspond also to 9. So instead of using straight lines to connect the point, we are going to connect it using smooth curves. Okay. Oh. Okay, so this is the graph of our parabola or our quadratic equation. I'm really sorry about my drawing skills. It is really difficult to draw using a tablet. Okay, I can't erase that. So this time, let's move to the last equation, which is f of x is equal to the square root of x. For this one, you have to list down some of the ordered pairs, or you can also use your knowledge about square root equations. And then draw a smooth curve. For example, we have 0, the square root is 0. For 1, the square root is 1. And also, negative 1. So, dalawa. For 4, you have the square root negative 2 and also positive 2. So, let's graph them. 0, 0, 1, 1, 1, negative 1. At 4, it is 2. And also, it can be negative 2. Finally, for 9, say for example, we have here 9. We know that it corresponds to negative 3 and also 3. So, drawing a smooth curve, we know that this is not a function from the examples that we did earlier. But what if you are only given with the graph and you don't have an idea what the equation is? So you can use the idea of vertical line test. So I have placed here a short definition for vertical line test. So a given graph is a function if any vertical line drawn passing through it intersects the graph at exactly one point. From our earlier examples, we know that this is not a function. Let's try to draw some vertical lines. If we draw a vertical line here, it will intersect our graph at exactly 2 points. So this will not pass the vertical line test. Therefore, this is not a function. Let's go back to our previous slide. We have here the graph of a parabola. In order not to mess up our original graph, I will place here a miniature of the graph. So if you have a parabola and you do the vertical line test, you will notice that for every vertical line, it will intersect the parabola at exactly 1 point. So it will qualify as a function. Same is true for linear equations. If you have a straight line and you do the vertical line test, for every vertical line, it will only intersect your graph at exactly 1 point. Okay? So now let's practice. What if you are given a function that looks like this, or a graph that looks like this? Do you think this is a function? Yes, this is a function. What if your graph looks like this? Do you think this is a function? No, this is not a function. What about this one? Do you think this is a function? Again, yes, this is a function. What about this one? Yes, this is a function. What about this one? Alright, this is not a function. So that will be the end of our lesson for today. I apologize for the errors earlier. I'm still adjusting to my new tablet. So thank you very much for sticking with me through the entire 20 minutes. Thank you and see you next time. Bye!